one of the things you also mentioned, I'm just gonna use it since it was in your message, is the terrain system. There's actually another thing I'm really looking forward to implementing, because it's going to be one of those components that lets you build really big worlds, but also like one of the things I feel is going to be very fun to play with, because you can, just generate like these big terrains. And the way I want us to approach terrain system is actually going to be built around ProtoFlux. So instead of like, the system sort of like being baked and very like, specific, the way it's gonna work is you're essentially gonna build, your own terrain, like, how the terrain should work, you build it out of nodes. So for example, say at the beginning, you can have, some input data. And this could be anything. This could be, say this could be like a height map, so have like some kind of like texture, that's like a height map. It's a very like, simple form of terrain. Height map. And then what you do is you can, you have like nodes that turn the inputs into some sort of like, visual representation or physical representation, like geometry. So you can have like, one that just takes a height map and it just, generates like kind of like chunk geometry out of it. And you plug this in, and this is gonna drive your terrain system. So this could be, just kind of like flat terrain, and it's gonna do stuff like, where some of the nodes you can specify this can be a grid of height maps. And this will handle stuff for you like, like LOD, where as you move around, it's gonna generate more detailed geometry. But you'll be able to like, do more complex stuff like this. Say you want, you want to like have also a splat map. So like, maybe have like a splat map, and this goes into this to give different textures. And maybe, you want to do some extra like vertex processing for certain types of terrain. So like, for example, if it's like, if the splat map indicates these are rocks, maybe you want some algorithm that says, apply this texture, apply this texture and pair through like, the geometry, so it's gonna, more rough, and, this will plug into this. So you'll be able to kind of like, build out a system you want, and like, build out the data structure you want, and it's gonna handle all of the kind of complexities for you, like, like the terrain being infinite and so on. What it's also gonna do is you'll be able to like, swap out the data sources. For example, instead of like height map, maybe, it's gonna be voxel maps. So like, we have like, voxels. And I'm just gonna do a quick representation. So these are like, voxels, like voxel data. And, maybe you can plug that into the height map generator. So like, it will do something like it's gonna check the highest voxel and generate geometry based on that. Or you have a different node, which instead will generate, terrain in the style of like, Minecraft, where it's like the voxels are actually, actual like blocks. And it's gonna handle all the complexity for you. You define, how each one of them looks and so on. You can like do a lot of kind of complex things. Or maybe there's gonna be another one that instead of like, it being kind of blocky, is actually gonna, generate like a smoothed out like 3D terrain out of these, voxels, so you have like stuff here, and it's like on the more, detailed. There's going to be lots of other systems, like for example, you can have another one that, also uses another map to populate it with like, objects like trees, vegetation, and so on. And the overall idea is like, instead of terrain system that's, fixed in how it works, we give you the building blocks and let you define, what your input data is, which can be voxels, textures. It can be procedurally generated. Or maybe, there's you do actually have like data that's, saved, but you have another node which, runs a function when you go into a new part of the terrain, you just generate whatever voxel data you want. So like if you wanted to do something like Minecraft as you walk around, anytime you try to load a chunk, that wasn't loaded before, it's gonna run this to initialize the data. And at that point, it just becomes data, which means it can be modified. There's going to be a number of nodes, and other mechanisms to mutate this data. So like if you try to something, like if you do like a tool or game, where it sends, modifies this data, this is going to trigger the system, and it automatically, updates the visuals for you and lets people, mutate the terrain. And it's going to be useful for both, the building tools, because you can make like a brush that, draws the system. Or if you're making a game, maybe you make it like, like a little like bomb, and you throw it and it explodes, and when it explodes, it mutates the terrain data to actually make a hole. So you can both use it for building the terrain and also to, create like interactivity with it. And the system is gonna be flexible enough to let you, do all these kind of different things. And it's the kind of general idea. And it's one of the reasons I also like, really look forward to it, because of all the possibilities. And the way, I feel this is gonna be approached is it's gonna make it overall simpler. And like you can combine the different nodes in lots of different ways to create like, terrains that kind of suit your needs. Like if you really wanted to, for example, you could have, you're talking about like a Minecraft importer before. One of the things I would want to happen at that point, once we have the terrain system, is where instead of just importing the pre-generated geometry for the Minecraft data, we just import the Minecraft data, into the data set up a node that's like, that's able to process it and generate the same terrain as the Minecraft. So that way you could actually still modify it, play with it and so on, because all the data is still gonna be there. And when I was like, I do have like some design notes, on this, and a lot of kind of design thoughts. When I was working on the Minecraft importer, I actually got like a lot of inspiration based on that, because I was poking around Minecraft substrate format, and it's kind of structured in a really interesting way where, like, if you in Minecraft, you have like chunks, and the chunks are very vertical, and they also kind of like split into these vertical kind of segments. And what the substrate format does, it encodes each one of these kind of separately, but it computes like a palette. So, like, if you're here, there's mostly like, gonna be bedrock, and it's gonna be, some stone blocks. So for this chunk, maybe the palette is, bedrock. And, well, now it's kind of deep slate, so I'm just gonna go deep slate. Deep slate, and maybe, there's some, actually forget, are diamonds at this level in Minecraft? I don't know. I mean, let's say a redstone, I don't know, redstone ore. So it has like a palette, and it can be like on a tree, and there's also obviously, air, like empty. So what it can do, if there's only 4 types of blocks in this particle chunk, it encodes this palette and it assigns each one a number. And you only need 2 bits to represent this. So like this one's gonna be, for example, 0, 0, this one's gonna be 0, 1, 1, 0, and 1, 1. And then to encode all the data in the chunk, each block in the chunk is just 2 bits. And if there's more of them, it's gonna, it maybe needs to use 3 bits or 4 bits or more. But what's really cool about it is the way they structured it. All of the names, like, they also have like, prefix. So for example, this one will have like Minecraft, Minecraft Air, Minecraft this. And it makes the format a lot more kind of extensible. So like when you use mods, the mods can add their own custom blocks and just, like, for example, there can be Aether, I was mentioning that earlier. There can be Aether and it has like, its own block. And they can add extra blocks easily without meshing with the others. Which didn't used to be true for the older, like, formats, before Substrate. Or Anvil. No, I'm messing it up. The Substrate is the library. The format's called Anvil. But they used to like store where each of the block, it actually just had like an ID, which means if a mod wanted to add another block, like eventually like official Minecraft would add a block with the same ID, and then now this would collide, and now your map is kind of confused. But they kind of came up with this system where it's both kind of more efficient and also a little more extensible. So when I was like poking around it, I got like lots of ideas for how our system is gonna work, and it's kind of like part of the reason I came up like with the whole like data layer, where you define how your data's done, and then you feed that into nodes that generate stuff like geometry from it, and other things. So there's a lot of stuff with this. I think I remember about the terrain system in particle quite a bit, but overall, I think this is going to be really powerful and a really fun system, you know, just to kind of play with and mess around and so on. So that's one of those things I'm really looking forward to implementing, and it's going to be built around, you know, ProtoFlux. I was probably going to be some Photodesk integrations too, but you know, you'll be able to like use a lot of the same kind of logic to like, you know, go down to the level we can also say, you know, how individual, like, you know, how are individual vertices of the terrain like modified.